Okay, guys, if you've already watched the intro explaining, you know, what I'm doing and what's going on with even this video, then you know that we're going to be making some 75 millimeter wooden clamps out of a piece of scrap wood. This is just a leftover scrap piece of wood that I had lying around the shop. And I wanted to make a video to show anybody new how to use VCarve Pro to generate the toolpaths for clamps for their CNC, and then also how to open that in the Onefinity and how to line it up in the Onefinity and how to touch off on your piece and cut it with the Onefinity. I don't have a touch probe, so I'll also show you how I touch off on this. So anyway, let's get into it. The first thing that we're going to do is I already have the software open, and I have just a blank workpiece here, 600 by 600 by 44. My machine is metric. It's set up metric. I work in industry. All the machines I service are metric. Everything I've done for the past 20 years or so has been metric, or actually past 16 years has been metric. So I use the metric system. But that's okay. It's not going to be a problem. What we're going to do is we're going to bring up our handy dandy calculator here for Windows. If you look, I've already done some conversions here. Anybody that's new, I'm just going to assume that, please don't be offended. I know a lot of the things I tell you, you already know, but there are people that don't know, and they need to know. So I'm going to cover it. So the conversion coefficient to go from imperial or standard is 25.4, and that's because there's 25.4 millimeters per inch. So what we're going to do first is we're going to measure our workpiece, and we're going to do the length is 14.5 inches. And I apologize for the graininess of this part of my video. That's because I'm using my camera that's built into my laptop. I have another camera coming, and I do have another camera, big camera, but I'm not going to turn it on for this. Also, I'm new to OBS Studio. I just installed it today, so I apologize if there are some flaky things going on here and there. If you've never done this before, I'm going to save you much time. So 14.5 inches. Okay, so let's go back to our screen here. So now we take our 14.5 inches, and we multiply that times 25.4, our coefficient, and we have 368.3 millimeters. We're going to highlight that and copy it. We're going to go, when you open your VCarve Pro software and edit, we're going to go job size and position. And what we're going to do is, if you look, we're going to make the X the long axis so that it's easy to line this piece up on our machine. Because, you know, we're going to have to align this, C to align this to make it somewhat parallel to our machine. My machine, I've already cut my grids. If you haven't done that, you need to. Anybody watching this video, if you don't know how to do the grids, say so. You know, post your comments in there, and you know, I might can do a video or something showing you how to do it. But all right, so our other measurement is going to be, and I'll go ahead and measure it and just tell you, trust me, please. It's 1 3/4 of an inch. So we'll pull our calculator back up, clear that, 1.75 times our coefficient, 25.4, and we have 44.45 millimeters. And that's going to be the height. Paste that in there, and now you see that looks like this, right? And then the next thing that we have to do is I have some calipers for this. I'm going to zero them. Then I'm going to come over and I'm going to take a thickness measurement, and my thickness measurement is 18.89, really 18.9 millimeters. So I'm going to go to the thickness and I'm going to type in 18.9 millimeters. Okay, now for doing what we're doing now, I prefer to touch off on the surface of the part, the workpiece, and then I'm going to use the center for the X and Y position, reference point or datum position. And that means that we're going to touch off on the center of our part. It's basically, or that's where we're going to align the X and Y. Okay, and then we just hit OK. Oh, it's single-sided, by the way. And there we go. So we're off to a good start. Now, this clamp is based on a clamp. I've already made a few of them, and I made we're going to make 75 millimeter wide clamps or long clamps. I've got some of them, but I don't have enough. The ones I have a 5/16 T slot or T slot nut stud slot, and I need 1/4 of an inch because when I ordered all of my 2.5 and 3 inch studs, they're 1/4 inch, and that's what I need for guitars, guitar bodies, and guitar necks, which is mostly what I do. So what we're going to do is we're going to overlook the length here, but the other measurements will get off this because I want to show you how to do it. I do have the file somewhere for this when I made them the first time. And then this little piece right here, this is purposely left here so that when you tighten the clamp up, this should be on your workpiece, and it means that you're guaranteed to apply pressure onto the workpiece, at least unless you screw up and butt up to that, but that's a different issue, different topic. Okay, so we're going to do 75 by 30 millimeters, okay? So let me swap back over. So what we're going to do, first thing that we need to do is we need to make sure we have enough different distance from the edge to clamp. And I've already calculated this. And it needs to be at least 18 millimeters. Or actually 18 millimeters gives us plenty of distance. That's because our end mill is 6.35 millimeters in diameter, and we want to make sure our end mill doesn't hit a clamp. And plus our workpiece is plenty big enough. And after doing the calculations, if you base it on 8 millimeters between, so like let's say you have 75 millimeters for the clamp, right? And then plus 8 millimeters, right? So that's 83 millimeters, and that gives you your clearance between the clamps to make sure that no bit chatter or anything makes you hit one clamp and accidentally dislodge it while you're cutting another. So really 85 would be better, 10 millimeters. But what we do is we say, if we say 18 times 2, and that should give us our 2 side distances, and we go back up to our job size, it's 368.3. So we go over here and memory store, paste, minus memory recall. So we have 332.3, roughly 332 millimeters left over. And when you do the calculations and you divide that, I think I did like 85, but we can know it's 84 or something, but you can get 4 pieces in here. So let's cancel this. We've already set this up. We're going to go, if you look over here in the drawing tab, we're going to go to where the vectors are, create vectors, and see a little squiggly Z line. We're going to hit that. That's a draw line. We're going to click over here. Well, wait, before we do this, go to edit, snap options and make sure you have smart snapping turned on. I'm going to show you what that does in a moment. Go back to draw a line. We're going to click here. You see where it highlights that little dot? That's at the 0, which is the center point for that axis. We start moving in that position, that direction, and type 18.0. And then we go over and just right click. So that gives us a good starting point for our piece, right? All right, so now we know that our piece is going to be 75 millimeters by 30 millimeters. So let's open this tool, which is the rectangle draw tool. And down here on the size, we want 30 millimeters for the height. We want 75 millimeters for the width. And if you look, 0, 0 is here. So it's minus 66.15 and 0, which we're going to snap to this, but I just wanted to show you this. We hit create, and there's your rectangle. All right, so now we have this rectangle. We're going to hit close. Click on the rectangle, and you notice the vectors are highlighted. Go to this tool, which is the move tool, and watch this as we hover. Did you see that? If I click right now, it's going to grab that corner. I move up, see it? How it turns to a crosshair. If I click here, it's going to snap, because I got smart snapping on, to the midpoint. And see how it highlighted that? That smart snapping just helped us by moving this entire triangle into this position. Okay. We're going to use this triangle to draw the 75 millimeter version of this clamp. Okay. We're gonna fix this piece also, but first we're gonna look at our piece here, and we're gonna consider our toolpaths right now. Okay, so we know that one's 75 millimeters. I'm going to take my piece here, and I'm going to measure the back. I'm going to measure the back here. See? And I measure that, and I've got 12.5 millimeters. Okay, roughly 12.5. It's wood, so. And the whole thing is 75 millimeters, right? So we pull up our calculator. We say 75 millimeters minus that 12.5, and we have 62.5 millimeters, right? Now, we got to do two things, or we need to do two things. When we go to carve this area here, we need to have just a slight overlap when we go to cut the pocket. And that's because we don't want a bunch of burring and all that garbage. We want a good, clean looking cut when we go to cut this thing out. So we're going to overlap it a millimeter. Okay. Since we know we're going to overlap that a millimeter, let's do it this way. We know we want to go 12.5 millimeters. So let's click on our line and click on our center point. Start going in this direction and type in 12.5. And there you go. I'm just moving. You don't have to move in a direction. I'm just showing you that it created the line. Now we right click and it stops. Okay. Now we look back at our calculator and we said 62.5 millimeters is going to be the size from here to there, right? We know that. But we really want to go past it. But okay, so let's talk about this for a moment. Our bit, our end mill, is 6.35 millimeters in diameter. So when we go to cut this pocket, right, that we're going to be cutting in here, if we only go to the edge of our piece, what's going to happen? You're going to have a radius of half. You're going to have whatever your diameter is, divide that by 2, so 3.175 millimeters, an eighth of an inch, 1.25 if you're doing standard. So an eighth of an inch, half your diameter mill. you're gonna have wood left over, right? We got to get rid of that stuff. And when we go on to this distance, we have to overhang it like that too. And we don't need to do that all the way down though, right? Because here we just need like a millimeter or so, just so it doesn't have a burr or anything. So what we want to do is we're going to start our rectangle here. We know our rectangle is going to be 62.5 millimeters in length, plus that millimeter overhang, so 63.5, right? Okay. Best thing to do is write that down, but 63 in here. I like to do this. Some people call this silly, but other people sleep and I don't. So sleep deprivation causes you to screw up a lot of things, right? Okay, so I'm going to pull this notepad over. Okay, so what we're working on right now is we're looking at our pocket. So we're going to call this the large pocket, okay? And we know the W is going to equal 63.5, okay? We know that. The width. The height goes back to this 6.35 millimeter, 6.35 millimeter diameter. Well, if you split that in half and you go 1/2 past this side and 1/2 past that side, that's still the diameter, right? So you still have to add 6.35 to it, but you also want to make sure you don't have little fuzzy crap and burrs and stuff. So the best thing to do is just round up a little bit and say maybe like 6.5 or 7. So if it's 30 millimeters right now, so if it's 30 millimeters, I'm sorry if I didn't record that. I opened Notepad's what I did and typed that in. So if our normal height is 30 millimeters, and now we know we got to add 6.35 to it, but we also want to add enough not to leave any burrs, and we really want like a 1/4 millimeter to 1/2 millimeter or so. I think the best thing to do is just go like an even maybe 7 millimeters, and it doesn't have to be exact. So 37, right? 30 plus 6.35, really plus 1, so 7 point, let's just say 37.35. Okay, so that means that now we're going to go over here and we're going to open our rectangle tool again. Got it open. I open my little notepad cheat window, and my width is going to be 6.35, and my height is going to be 37.35, and that's good enough. Okay, and that's because we're going to snap it. We got smart snapping. Let me back up. I'm sorry, I'm moving too quick. Go to the transform objects. This icon is the move icon, and if you look, it makes sense. It's showing a rectangle and an arrow, and it's a ghosted rectangle and then a dark rectangle, which means it moved it from here to here. If you look, that's the resize tool. You got that ghosted small square, and now it's bigger, right? So anyway, yeah, rotate, same way, mirror. Anyway, so we're going to go to move, and we're going to click on this, and when we say our crosshair for our smart tracking, we're going to click on it and go to the end of that little mark that we put in there, or that temporary vector placeholder, so that it's aligned here. And now you should be able to imagine that when we start cutting this pocket, what's going to happen is we're going to carve all this material out, is what we're going to do, right? So this is going to be pocket 1. And now we can delete this witness mark because we don't need it. Okay, so now we have another measurement that we have to get. Okay, and this other measurement, the height is going to be the same as the one we just had. It's the width that we're not sure about, right? So the large, how about that? Sleep deprivation. All right, and we'll call this the edge pocket W equal, okay, and H equal. The height is 37.35, and what we're going to do is, because we do have the original, we'll put it back to camera, we're going to measure this area right here, this area, okay, so from here to there, from that edge to where it butts, and it is 7.8, it looks like millimeters, 7.5 millimeters. We'll just go, yeah, we'll go 7.5 millimeters. Okay, and all I did was type it in my little cheat sheet. That's all I did. Okay, now that 7.5 millimeters is going to be from this surface to the edge, and we still want that 1 millimeter overlap. So that 7.5, we're going to do 8.5, and we're going to butt it up on this surface here. So now we go to our rectangle tool again, pull up our little cheat sheet, and we have 37.35 and 8.5, and create. Okay, close this, highlight your new rectangle, go to the move tool, smart tracking to the center, bam, there it is. Okay, so now let's do some housekeeping before we do this other part. Okay, so you see your tabs here? There's a layers tab. Let's go to the layers tab, and right now everything's on layer 1, and that's okay for something as simple as what we're doing, but we're going to right click here, insert new layer, and we're going to call this layer large pocket. And let's make that color, let's make it blue. Okay, and let's click on this large pocket and go to, by the way, that's a right click, move to layer large pocket. So it's blue now. Housekeeping. Okay, so now let's go over here again, right click, insert new layer, and let's call this one front edge pocket, and let's make this one green. Here, let's make it that. Now I'm going to select this one and move it down. Let's click on it, move to layer, front edge pocket. So now those are on different layers. And then this layer, let's rename it, and let's call it parameter. Okay. All right, and let me pause this a second. Okay, sorry about that. I thought my dogs were trying to destroy the house. So, okay, so now we have the perimeter, and it's black, We have this pocket and this pocket. So now we need the T-slot stud. We need the slot for it, and it's 1/4 of an inch. And we want it to go from here, and we want to leave like 2 millimeters off of the front here. I think I did 3 on the original. Don't remember. Doesn't have to be exact. No, I did 4.5 almost. Okay, we'll do 4. So let's go back to, well, here, let's create a new layer. And this is going to be called T-slot. We'll just call it T-slot. And this one's going to be, let's make this one like orange or something. Okay. I don't want to use red because that's a selected vector. Okay. So now what we need to do is we'll go back to the drawing tab, and we highlight, we make sure that we select the T-slot layer. And by the way, you can do that here too. See? Okay, we'll go back to drawing. And now we know we want to go in 4 millimeters with this, right? So we're going to draw another little reference mark here, 4 millimeters. Okay. And now we're going to do rectangle, and we, oh, wait a minute, let's get our measurement. Okay, T-slot. The T-slot is the width is going to be 6.35 millimeters. We already know that. So 1/4 of an inch, but we need this distance. So we go to this little measuring tool here, and we go to the end of the little line that we drew for reference and to here, and it's 51 millimeters. So we go L equal, you don't have to do this, but like I said, I don't sleep very much lately, so all right. So now we still have that in here. We're not going to need it. We're going to go to the rectangle, and we want 51 and 6 point, it should be 35, it's a typo. So this should be 51, and then this should be 6.35, and create, and then close. So the reason I said we really don't need that now is because we're going to go to our move tool, and we'll move that to the center, and we can delete that little line. Okay, so now we have to put, we don't have to, I mean, we can leave it the way it is, but that's not the way it's going to be cut because we're using a round tool, right? We're using a cylinder. So anyway, sharpen cylinder. All right, so we go to here, draw circle tool, okay? And already had it on 6.35 millimeters. You can select radius or diameter. And what we're going to do is Y00 X minus 5, 4. All right, hold on 1 second. Okay, and this is the right diameter. So we hit create, and then if we go over here, it's and point to it. It shows the X is minus 103 point something. Don't have to be exact. We're gonna move it 103. I just want it to spit it out close by. Hit close. Just like before, highlight this, move, go to the edge. Same thing here. Go to the edge. Okay. All right, and then close. Now what we're going to do is we're going to make this look like a slot. And how we're going to do that is, see the little scissors over here on the Edit Objects? This is our interactive trim tool. And we click on it. If yours isn't checked, see this little box that says Rejoin Trimmed Sections automatically? If you check that, leave that checked, watch what it does. We go through here and snip, 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 snip. And if you look, it joined it back into one closed vector for us. So now if you sit and you look at this, now you can imagine the clamp, because here is the portion that is the tallest portion. This is the chunk, the middle piece that is down by like 4 or 5 millimeters below that, and this is the little lip that actually clamps onto the part. And the difference is here we angled this, right? So here's what we're going to do. We go back up here to the layers, and we select the perimeter layer, okay? And we're going to draw a 17 millimeter line here. Sorry, I was going to do it. I need to wait and show you. Click on the line. We'll just go right here. Click, go up, and type in 17 millimeters. Okay. Now that vector's highlighted. Go to the Move tool. We're going to snap to the center, and we're going to drop it off on the center. Here's why we did this. Okay, we're going to close this. We're going to take another line, and we're going to go here to that edge and to here. We're going to do the line again, and we're going to go from that edge to here. Okay. Now we're going to take our scissors again, and we're going to snip, snip, and close. And if you look, you have a closed vector, and here I'm going to highlight that one line left over from snipping, or left over from drawing for reference. And now what we have is we have the perimeter of the clamp, and it actually looks like the clamp. Okay. I'm going to do something I haven't done. I should have told you to do. As you're getting this far into it, always hit save when you start getting some of this stuff done. And this is a 75 millimeter clamp with 0.250 inch slots. And save. Okay. So now it's starting to look like a clamp. Okay, I got to pause it a second, and I'll be right back. Okay. Sorry about that. But actually, to you, I wasn't going. All right, so if you look, we just have these really sharp edges to deal with now, right? All right, so if you look here, if you go over to Edit Objects, you see this little, where it looks like an arrow of sorts, and then this part is grayed out, and then the red part is rounded. So this is the fillet tool. So we're going to click on the fillet tool, and I'm going to fillet these edges 3 millimeters, and I just happen to know that that's what I like based on already doing it. But here's what I want to show you. If you go, like, you see the little plus sign, watch what happens. See the little check. Once you see the little check, it means you can fillet it. Watch the little check pop up. See it? Watch this. See the check mark? Nothing, 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 and check mark, right? Okay. Now these two edges, I only fillet them enough to not have a sharp edge because this is a clamp piece. So I'm going to fillet that 1 millimeter. Check. There we go. Okay. So now it looks like a clamp. Okay. So now we're ready to where we can, or at least we can start getting ready for some toolpaths. If you recall, when we first started on this, we decided that, hey, there's enough room in this scrap piece to do four of these little clamps. So that means that now all we have to do, that we have all of this part done, is just replicate it, right? Duplicate it. So what we're going to do is highlight all this. See where you see the offset and layout area? All right, see this segment? You have, like, this is the offset, which shifts vectors in or out from the original. This is a ray copy, and I'm going to show you what it does now. We select it. We have this entire deal here selected, and rows would be on top of each other, columns would be side by side. We can fit 4 of these, so that would be 4 columns. And what's really cool is we can do this by, the spacing can be a gap or an offset. And what we want to do is, because we know that we're going to have this, and then we're going to carve another, and then another, and another, and we have this end mill to deal with, we want to have a gap. And I think I have it set on 9 millimeters, and hit copy. See what it did for us? So now you have 4 of these. And we hit close. We'll go ahead and save it. All right, so now we're ready to start generating some toolpaths. Now, if you go over here to the far right, right below the close button, and you see the toolpaths tab. When you click on it, it comes into the window, move away from it, and it disappears. It's auto hide. Right now it's on auto hide. See right here, this little thing that looks like a pin or thumbtack. That's exactly what it is. And if you click on that, it'll pin this where it won't disappear on you. You don't have to, but that is my preference when I'm using it, to keep it active. And another thing is, we're about to generate some toolpaths, so we want to see them. So we want to see the 3D view also. Well, you can show both views over here. You can have side by side. And since we're working on a long piece, it makes more sense to do top and bottom. Okay, so what we're about to do is we're about to do a pocket. We're going to do this pocket, which is the whole thing. We're going to do the slot. We're going to do this pocket, and then the perimeters will all be last. But we need to have a brief discussion concerning our strategy. So people like us who already support factories, we already know time is money, and we never want to leave a machine sitting for long periods of time when it has money invested into it. And we also don't want that machine to have a whole bunch of wasted motion, right? And if you can cut a part in 5 minutes versus 8 minutes, now you just shave 3 minutes off, which is substantial, right? So now you just increase your throughput every hour. And what we need to start looking at, even with our home shops or our home workshops, is our time. Our time is very valuable. So what we have to look at is we have to look at a strategy for what we're doing. Okay, we know that we're cutting. We're going to carve out a large pocket. We know we're going to cut a slot, and we know we're going to cut a small pocket, and then we know we're going to cut a perimeter. It makes most sense to cut one piece all the way through, except for the perimeter, and then work your way down, because it's less wasted motion. And the only reason why you wouldn't want to cut the perimeter yet is because you wouldn't want anything to shift and you aren't finished, right? So the safest thing to do is cut all of them out at the end. So that's what we're going to do. So what we're going to do is we're going to, and I'm going to switch screens again. We're going to generate each one of these tool paths individually. So we're going to have a bunch of tool paths, and then we're going to move them to where clamp 1 is all together. And then we're going to generate clamp 1, and we're going to generate clamp 2, and generate clamp 3, and then clamp 4, and then the perimeters. And you'll understand a little bit better once we do it. But that's what we're going to do. Okay, so what we'll do is we got this far, and I'm going to stop this one so I can upload it. I'm still going to continue, but it'll be in a separate video because it's going to be a long video. So anyway, catch up with me in part two, which is coming up right up, or within just a little while of the first one. And then there, we'll be doing Toolpath.